All right, this is going to be a fast talk about indexing with a focus on, given a select, how do you make an index that works best for it? I'm going to cover several things. I will not cover full text or spatial, skip technology, a few definitions. A primary key is a unique key. Some people don't know that, and they duplicate unique key. Not good idea. It's clustered. I'll explain clustered as we go along. A unique key is an index, so you don't need both a primary key and an index, or a unique key and the same column indexed. The words index and key are synonyms. A secondary index is an index that's not the primary index. You can have only one primary index, but you can have any number of secondary indices. And the secondary index, by definition, will not be clustered. Clustered, first part of the definition is, it means it is co-resident with the data. The data is sorted by the primary key so that you can go alphabetically or whatever it is, numerically, alphabetically, through the data based on the primary key very efficiently. Covering is another term we'll get to in a few minutes. It says that all the columns that are anywhere in the select statement exist in the index. This makes it a little more efficient because now it doesn't have to look both at the index and the data. Note, the secondary index and the data are stored in two different B trees. When you look something up by a secondary index, first you drill down the secondary index, and then you reach into the data via the primary key to find the rest of the row. If you're covered, you don't need to do that second step. A composite key, newbies don't think about this one. That's where you say index A, comma B, two columns. Last name, comma, first name is a common usage. It's better than two separate indices. All right, filtering. The where clause filters out which rows you want and it skips the others. These are very efficient filters. It says, I just want X where it's 123. If you have an index on X, that means drilling down the B tree to go right to X, right to 123. Filtering with the in clause, now you're drilling down in multiple spots in the index. This is not quite as good as equal, but it's not as bad as select. On the other hand, in select, where you have a subquery generating the things that you want to look for, that's terrible. Don't do it. Avoid it. There may be a few cases where it works well, but no. Instead, turn it into a join, and I think I'll have an example of that later. And in fact, here's later. I don't want to go through the details here. It's in the slides. The slides will be online if they aren't now. Apparently they're not. And it shows a simple mapping of the in select into a join that does functionally the same thing, but much better. Hold the comments for a moment. A range is where you're doing between or less than or things like that. A like, as long as it doesn't have the wildcard at the beginning, is also a range. Anything beginning with foo, well, they're all going to be consecutive in the index. So that's a range. You're looking at a range of numbers within the index. A select, except for rare cases, will only use one index. There's a link. There'll be many links. Again, you'll need the slides to get to the links. Index merge sometimes happens. That particular case gives you an example of an index merge and says why it's not as good as using a composite index. All right, now, your question? One question, you get it. Hold the rest till the end.
You just said the subquery is bad, right? But how about the exists? Same.
In select is bad, exists subquery is not as bad. It's often very good, and there are cases where that will actually speed things up. Some examples, and we'll get to the algorithm later. You might have what I have here is two selects and then two indices that go with it. Those two selects look at A either with an equal, which is drilling down looking for one item, or with a greater than or equal, which is drilling down and then scanning from there. Index A is perfect for both of those queries. The composite index A comma B is nearly as good. It just happens to have B cluttering things. Another example, where name equals Rick, that's me, or name alike are percent, a range. Again, index name, perfect. Index name comma something else is still good. My point here is that if you already have the two-column index, it's going to work for this case where you only need the first column. Not the second, but the first. Some people ask, does it matter what order things are in the where clause? The answer is no. Both of those where clauses are optimized identically. That composite index, where it mentions both of them, is perfect for it. And in this case, it actually doesn't matter which order, but order does matter in general in indexing. With index A or index BB, it helps with the query, but it's not as good as having the composite index. Now, we're only talking so far about ands. We're not talking about or. If you say where A equals this or B equals that, you've got a mess. It's essentially unoptimizable with some exceptions. Avoid or. Of course, if you can't avoid or, you got to use it. Now, what if you have an equal and a range? Starting with the equal is good. Moving on to the range is a second part of a composite index is perfect. What it can do is drill down to where A starts in the index, and then further drill down to where B starts with 345, and then just scan forward from there. Everything it needs is consecutive there. Index A, well, that'll do the part that drills down to A. If you have index BB, well, that could do the other part. Neither of those is quite as good. And this bottom one is no good. Well, no better than just the index B. The A part doesn't help. It's unused. It'll be ignored. Now, here's two ranges in the where clause. You can't use an index with both of them. Or rather, the index won't help you any. It won't help you more than dealing with one of them. So index A, okay, that'll take care of the A. Can't take care of B. Index B, that'll take care of B, won't do anything for A. And then you can move on to combinations, like C has an equal followed by something with a range. Moving on. Covering. I briefly mentioned covering before. So, in this example, we're only looking at the column Y and the column X. We want to use Y for filtering to find the row with Y equal 5. And then guess what? We've got the value of X right there. So we're finished. We don't need to go find the whole row. This is called covering. And it's better than simply having index Y, which is, we'll see in a minute, the primary thing that the algorithm will tell us to do. Here's a slightly messier example where we have 3 variables, Y, Q, and X. We also have the 2 ranges, which won't be fully usable. But if we throw everything into the index, starting with something that we can filter on, then we get the benefit of covering. A B tree. Look in Wikipedia for B tree or B plus tree. It describes it pretty well. There's the link. It is very efficient at locating a single row, given that you have a key, or a range of rows based on those keys, the key. Hash is a competing index format. It's good at finding a single row, but terrible at a range of rows. And for that reason, I would argue that MySQL does not have a hash index, except for one obscure case. And B-tree is an excellent overall indexing method. The plus in B-tree means that there's some extra low-level stuff that makes it even easier to do the range. You start here and go forward. The data in an InnoDB table, I'm talking only InnoDB. If you have MyISAM, these slides don't cover it. There is a link to an older deck that does cover MyISAM. You should be away from MyISAM. It's dying. Don't use it. So InnoDB's primary key is clustered with the data. The leaf nodes of the data B tree contain the entire rows. The tree is based on the primary key. Secondary keys are also B trees sorted by the secondary key, but what's in the leaf node is the primary key. So when you look up something by secondary key, first you drill down the secondary B tree, and then you reach over into the primary B tree to get to the bottom and find the record. A rule of thumb, tomorrow I have a talk on Rick's rules of thumb, Rick's rots. One of them is the fan out in a B tree is 100. So this node has 100 things under it, which has 100 things under it, and so forth. The corollary of that is a B tree is not very deep. You got 1 million rows, it might be 3 levels deep. 1 trillion rows, 6 levels deep. We're not talking huge, deep things. Okay. I would like other questions to be held at the end. Anybody got one question for this section? Moving on. The algorithm. Now that you have examples of most of the algorithm, let's try to lay out how to do it. First, we're not going to handle or in this algorithm. We're not going to handle in. And we're assuming the where clause is a bunch of ands, things anded together. We'll deal with some of the exceptions later. So first, step 1. If you got some things that are equal, A equal 5, B equals 7, anded together, find all of those. And this has to be column equal constant. So find those columns, lay them out as the first columns of the index that you are now building. Doesn't matter what order. As I said before, the where clause doesn't matter. And in this case, so far, it doesn't matter what order in the index. A common wives' tale is put the most selective one first and do the others later. Another way to phrase that is cardinality. Use the one with the most cardinality, whichever it is. I claim cardinality doesn't matter. Ignore that. Step 2. Now you have one more chance to add one more column. It'll either be a range, one range. Notice we already said 2 ranges. We can't do the second one. It may be a group by. It may be an order by. I'll get more details in the next 3 slides. So, if you have A equal 1 and B greater than something, you've already put A in the list. Now you get one chance to put B in the list. And great. Now you stop. You can't go any farther. There's no use looking at the order by or the group by or the limit. If instead you don't have a range in the where clause, but you do have a group by. Notice there's this extra qualification. You've done everything in the where. There's no ors, nothing other than what can be done with equal and. If you've gotten past the where clause, now you have a chance of consuming the group by, or we'll see in a minute, the order by. So we got the where. Now you can throw in all the columns of the group by in the same order on the end. Stop. You won't get another chance. You can't go under the order by, sort of. If there was no range and all the wheres handled and there's no group by, this is not quite right. If the order by is identical to the group by, then those two have essentially been merged together and are done in the optimizer simultaneously. So I'm not quite right here, but anyway. If the order by has everybody ascending, good. If everybody's descending, good. Something that often happens is order by date descending, comma, ID ascending. Not good. This is not good because you can't go both directions. Can't switch direction in the middle of an order by until you get to 8.0. And I'm not really going to cover how 8.0 solves it. Most of you are not on 8.0, correct? Correct. Are most of you on 5.7? 5.6? Anybody older than 5.6? Well, yeah. I spent, I don't know how many years trying to get a system off of 4.0. Anyway, so if you get past all of those, then you've consumed the order by. You can put the order by guys on the thing. All right. What I said in the previous one is covered here. You've consumed the where, you've consumed the group by, and the order by is either missing or identical and in the same direction, all the pieces. Then you have a chance of getting to the limit. It sounds tempting to stick a limit on everything in hopes of speeding up the query. But if you haven't gotten through this, the limit isn't going to be performed until all that other work of sorting, grouping, etc. is done on everything that the where clause didn't throw out. So only if you get to here is the limit going to speed you up. Now, When you do explain, it'll say using temporary, using file sort. If it fails to get to the limit. With the limit, it'll stop delivering rows as soon as it has it. But if it's already done a sort, that means you've already done far more work than the limit is trying to save you. If you have offset, or a limit with two numbers, the offset, the code has to step over all of those rows. So it's as if you fetched all of those rows and threw them away immediately. Offset is not that beneficial. Now, for every algorithm, there is an exception. This is one of the exceptions. Sometimes the optimizer will say, I'm going to ignore the where and the group by, and I'm just going to look at the order by. It's going to say, oh, maybe I could just scan through things and do the filtering as I go. So sometimes having an index just on the columns of the order by will actually work. Sometimes the optimizer will look at it, flip a coin, and the coin will fall wrong. You probably have a query that is essentially impossible to optimize. Question for this group, this section? We might have time for lots of questions at the end. All right. What works, what doesn't? A lot of things that won't work well, and I'm going to cover some of them. All right. Hiding an indexed column in a function means that that index cannot be used. Here are some common things that people do that destroy the use of the index. Date of something, year of something, lowercase, cast, even implicit things like change the collation during this comparison. That's essentially a function on X. It prevents the index from being usable for optimization. A good discussion of what this is about is the term sargeable, and see Wikipedia for what that means. Nice discussion. Another killer is leading wildcard on a like. If you're looking for somebody with the last letter of his name being S, how are you going to find James out of that? How many other names end in S? If they're alphabetical, you got to search the whole thing. Of course, if you got the where clause hitting different tables, it can't do the index on all the tables. An index applies to one table only. There used to be a storage engine that did other stuff, but never mind. Negatives tend to be bad. There are exceptions. And I waffled here. The exceptions tend to be in newer versions. Older versions are pretty bad about optimizing these. Flags. Index a flag. Half the rows are true, half the rows are false. Put an index on that flag. Optimizer's going to say, why bother going to the secondary index, reaching over for half the rows into the data? That's a lot of work, a lot of extra work. Why don't I just scan through all the data and throw out half the rows? The optimizer correctly ignores the index. Conclusion, don't say index flag. Don't index things like that. On the other hand, if it makes sense to have a composite index, here's an equal followed by a range, the optimizer will do a decent job on that. Or I said OR is bad. This is a possible workaround. I say possible because it's usually clumsy and you may not want to bother with it. And if you have multiple ORs or whatever, it could get really bad. Note, I'm testing two different columns for values. I'm not looking at the single column. That's a simpler matter. So this is a way of turning an OR into a union. And what will happen is, whoops, get my fingers right. If there's an index on A, this first select will probably use it. If there's an index on X, the second select will probably use that. So these two subqueries may be very efficient. The big table, there's only one, there's 10 rows with A equal 1. That's good. There's overhead for the union to collect the pieces, put them together, deliver them to you. And if you know those aren't going to be the same row, then make it union distinct as opposed to union all. Union distinct, which is the default when you just say union, requires a deduplication pass. So union all is faster, but you might have duplicates. And rather than bringing up another slide, I threw in how you would do order by and limit to get only 5 rows out of this whole mess. And the idea is to find 5 rows from each of the select that gives you up to 10 rows for the union, and then whittle it down to the 5 you really wanted. This is a little more complicated on the whittling it down. If you're doing pagination with a union, you need to get the max possible from each piece and then do the offset and limit. Now, in general, I don't like using offset for pagination. It leads to bugs and inefficiency. So there's a link on ways to deal with that. Ascending, descending. Note, I said both ascending, both said descending, good. Mixture, bad. Already covered it. Prefix. That's the paren some limit on, like you're taking the first part of a long string. It's necessary with text or blob because indexing doesn't work on huge data types. And generally, the optimizer avoids it, or even when it does, it isn't necessarily going to do the best job. Here's some examples of why it's really bad. When you say unique with a prefix, it is saying only the first 5 characters of this are unique, not the whole string. So that's probably not what you wanted. In the second case, it can't really get past the first column to get to the second. So again, useless. All right. I've got this file sort. I've got this using temporary. That's terrible. I got to get rid of it. No. When you have a group by, order by, you need it. You asked for it. And if you have group by one thing, order by something else, you possibly have 2 temporaries and file sorts. Most of what I've said elsewhere is an attempt to avoid the need for file sort temp table. Another thing, which I may cover later, file sort doesn't necessarily hit the disk. If possible, it'll do everything in memory. The word file is just simply confusing, misleading. Dates. There's some handy ways to do things, but they avoid the index because you're hiding in a function. You just want the year and day, a month, or here's 2 ways to do that, or you just want the year. Here's the best pattern I've seen for how to do a date range. Note, it has the same date there twice. One says greater than or equal, the other says less than. And I say, okay, well, I wanted 3 months. Note, month is not plural. So I get all of this. I avoid so many things. I avoid the, how do I get the next year? How do I cross the leap year? And how do I avoid getting the less than was to avoid including the last day or second or microsecond. And it works for all the things equally well. Same pattern. So many people mess this up, but usually it doesn't matter because they're only including the midnight of the next day. But they're busy tediously computing, okay, is this February 29th or not? Moving on. Question?
Your point about prefix indexes, and saying that you don't recommend using them for bar chart. What about a situation where I have a bar chart with 28, but prefixing, just indexing the first 30 characters gives me 95% selectivity? Wouldn't it be useful to just index the first 30 characters rather than?
I've seen that only in one rare case where it was useful, and that was otherwise the index would be huge on disk and you're running out of disk space, yada, yada. So it shrinks the footprint of the index, but for most situations, it hurts, not helps. So I say avoid it wherever possible. Or your mileage may vary, or give it a try. Primary keys. Okay. InnoDB really wants a primary key, and it's really good if you specify the primary key rather than letting it default. Usually the best, in my opinion, is to find a natural key, something in the table that is already unique and could be used as the primary key. A common fallback is to use an auto increment. Add an extra column that's an int, unsigned, auto increment. Unsigned, not null. Don't make it big int unless you really expect to have more than 4 billion rows. UUIDs, GUIDs, etc. are terrible when you get a huge table because the random access will lead to I/O, which will, remember, I'm talking about a huge table, will lead to disaster performance-wise. An argument for explicitly having a PK is someday you will need to do some maintenance on this table, and if you can't uniquely identify each row, it may be difficult to do it. So, the natural key avoids the extra column. It's faster access for the column that's in your primary key. It works fine in most cases. It may help in making more things covering. Remember, the secondary key includes a copy of the primary key, so really you've got more columns that might be covering some queries. Auto increment. Okay, what if your natural key is a varchar 255? Well, an int is much less bulky, and secondary keys are shrunk because now you don't have a copy of it there. But if you do the math, if you have one secondary key, it's an equal trade-off. 2 secondary keys, okay, this argument starts to make sense. A subtlety about auto increments and several different kinds of operations, you need to keep an eye on the value, the max value of that field, because it could go wild. It could overflow. And here are some ways that it might overflow. Insert ignore, first grabs the IDs that it might need, and then says, oh, I didn't need them all, I'll waste them. Ditto, ditto. replace, if you're using the replace statement, then seriously consider replacing it with IODKU, which is the line above it, the insert on duplicate key update. It makes more sense, it's probably more efficient. A replace is literally a delete followed by an insert. IODKU says, okay, let me check. I need an insert or I need an update. Question? This section? Miscellany. Okay, we might finish before the time's up. Okay. I very carefully say one select will use one index. By that I mean, if you have a subquery, that's another select. If you have a union, that's multiple selects. I already gave you a union example where the two selects in the union were using different indices. Don't use force index unless you really have to. Today, you'll fix your problem. Tomorrow, the data will change and the force index will force the optimizer to use the wrong index. You'll be shooting yourself in the foot in the long run. It's better to spend extra time trying to figure some other way to make it work right. This limit with a huge number is too obscure for me to discuss. You might see it sometime in some obscure thing. 767. If you're in 5.6, you probably hit a bug that finally went away in 5.7, wherein you get the error max key length 767. I'm not going to let you create this index. There are multiple workarounds, and I felt it was worth listing them for as long as 5.6 lives. It usually comes from when you upgraded to UTF-8 MB4, which might use 4 bytes per character instead of UTF-8, which uses only 3. And 4 times 255 exceeds the limit, yada, yada. I'll just leave that as reference. Redundant indices. Get rid of the extra indices because they're wasting space on disk. They're slightly slowing down inserts, and they're not helping with anything. You got 2 indices that say the same thing. Well, optimizer will pick one. Why have the other? Some common things I see. I'm on forums day and night. I've seen thousands of questions, and I see this one all too often. It's not a question because the guy doesn't realize he's doing something dumb. Primary key is a unique key, is an index. Don't say ID again. When you have a composite key, anything shorter than that, the left part, is essentially being handled by the longer one. So drop the shorter one, let the longer one serve the purpose. The order in the index matters, especially when you have an equal and a range. So this pair may or may not be redundant. You need to know what your selects are. Back to the forum. I see there, show create table. I say, hey, you don't have a primary key. Bad. Hey, you've indexed every column and there are no composite indexes. Bad, bad. You got redundant keys. Bad. And some people are still doing comma joins. Here's a simple example of a comma join and how you would write it in the preferred syntax. These are identical, they're compiled identically, everything works identical, just that the language has moved on. Get rid of the commas, use join on. And when you use join on, be sure to have the on say how the tables are connected and the where say the filtering. When you get into the low-level details, you'll find that the optimizer doesn't care where you put things. This is clarifying to the reader what you mean. Partitioning, don't partition. It's useless, with a few exceptions. And that's my blog on that. If you have a partitioning thing that seems like it's working well, I'll bet you I can write the equivalent thing if you're willing to change the indices differently to compensate for what the partitioning was trying to do. The exceptions include a time series where you're deleting old data and inserting new data. Drop partition is much better for delete. Another example is a two-dimensional search. And that gives the other two examples too. So haven't covered joins yet. You got two tables joined together. They're joined on some column. And they've got where clauses. So how do you do it? Well, first of all, note that the optimizer will, I think always, pick one table first, go through it, filtering, and then reach in to the next table. If you've got three tables, then bing, ding, ding, just keeps going, reaching into the next. So which one's going to be first? Probably the one that has the best where clauses. Probably not the one that says left join. But sometimes the optimizer says, oh, you don't need left. I can see that it doesn't buy you anything. But it's definitely not the order you put them in unless you said straight join, which is along with force index. Don't do it. So what happens next? So let me use this example to reach into what you do for the second table. Well, first of all, the first table has a where clause, and so it picked B as the first one it's going to look in, the optimizer will. And it needs index Z to do the filtering. Now it's going to reach into the other table, and the only thing it has is, okay, got to reach in via X. So those two indices work best for this query. Of course, queries can get messier, so I haven't covered that. Questions? What? Private. There's no need for the index on Y. You've fetched the row, you fetched the B row, so Y is sitting there. Note, I said select ... I'm not saying what's there. I'm not telling you whether a covering index would help. Perhaps you weren't thinking that direction. But there's no need to index Y in this example. Table A is unlikely to be first because the where clause, yes. Yes. If it picked A first, then index Y would be useful. So you may end up having to do multiple indices just in case the optimizer does one thing instead of another. Yes. It will tell you based on what it knows. It won't tell you based on the index you haven't yet added. And then explain is, you sort of can't think of the future.
Just want to point out you have a typo.
Join. Thank you. All right, some patterns. All right, many-to-many mapping. You should probably see the slides to study this. Notice I have 2 IDs off to other tables. There may be other columns, and I've got a primary key with 2 columns in it, composite thing, and an index with 2 columns in the opposite order. No auto increment, it's a waste. Make sure the IDs are minimal size and unsigned, not null. Use NODB, because that gives you the clustering of the primary key. The index lets you go the other direction. And these are perhaps the best way to conditionally insert into this table. Presumably, you may already have the items in it. Normalization. That's where you have a name and a mapping to an ID, using the ID to keep the other table smaller, but you got to look it up by name. So we have 2 keys, primary key ID. That takes care of the auto increment being done, the unique name, because you need to look up what the ID is for a given name. If you're using WordPress, tell them to change to these indices. I'm tired of helping people who have the horrible indexes on the meta key table. This is better, much better. Note the primary key gives you the direct track with a composite, 2 columns, into what you need. I don't know whether the secondary index is needed. It's a minor issue. Note, I got rid of the auto increment ID. It was a waste. And if you hit the 767 problem, in other words, these are varchar 255. If you're in 5.6, if you got UTF-8 MB4, you probably hit it. Go back to that other page that tells you what to do here. Okay. Got to run. All right. Open up your smartphone and rate the session. But okay, what do we have before questions? Okay, these are the slides. They're already online. They're just not online through Percona. This is a previous version. It includes my ISAM and some other stuff. This is how you can get to me. This is 20 or 30 blogs on various things, some of which I gave you links on already. And if you want fast response, go to Stack Overflow and tag a question with both of those, and I'll probably see it soon. Questions? Too fast?
On your, when you were going through your algorithm and got to the group by clause, you made a reference to putting them in the same, putting the columns in the same order. I wasn't quite sure what you meant by the order of the columns.
Group by A, comma, B.
But that's kind of like arbitrary, right?
Okay, you're right. My mistake. It's
5.7, but you order by because why you give the ordering on group by so correct. You actually want to have it in the order. If you want to use an index for a type, order you should have it in the order of the group by. Correct. So avoid the mistake.
Yeah, match the group by and the order by. That has to be done. But if it's just a group by, still. Oh, well, that's always been the case in MySQL. There's an implicit order by with a group by, unless you say order by null. Okay, I will try to take a note of that.
I noticed that you said try to use a natural key. Do you have any concerns about fragmentation due to that? And secondly, I didn't see any advice about using a monotonic key to increase the ID to avoid that fragmentation.
Well, a unique key will be monotonic once it's been sorted in its order. Did you mean consecutive, no gaps?
For the primary.
Doesn't matter whether it's consecutive with no gaps. Yes, there could be fragmentation. B trees naturally keep themselves somewhat clean. Don't worry about fragmentation. As I'll say in Rick's rods, don't optimize table. It's almost never useful. Don't worry about fragmentation. That's the bottom line.
Can you give us an example of the index merge?
Index, well, the link gives you an example of index merge. This is there's at least two cases of index merge. One is intersect, where first name equals this and last name equals that, and you have an index on first name and an index on last name. So what it will try to do, if it decides to use index merge, is find the IDs from one index and the IDs from the other index, and then do an AND on those two lists, and then go look up things. A lot of work. If you had the composite index, it's all done at once. The OR case is where A equals 1 or B equal 2, and you have indexes on each. Then it will try to do the union, the whatever, the other case. That one could be useful, but it's rarely invoked. Partially because it's a lot of work to do all the overhead, to pick the pieces up, throw them somewhere, put them together. So index merge, you can almost forget about it. And use composite indexes or covering indices where practical. That will give you better results.
So on a secondary index with low cardinality, you mentioned sometimes it just skips it, scans the whole table. Do you have any more insight into whether when it decides to skip it or not? Because I see that change on like a minute by minute basis from explaining.
Rule of thumb, 20% of the table.
5%.
Reality, I've seen 10%, I've seen 30%, and it's based on the cost model in the optimizer, so I can't predict. 20% is a rule of thumb. And if you had most of the table true and a little bit false, it will do a table scan for true and an index usage for false. So it will dynamically decide which way to go, which is perhaps something that other vendors don't do. They compile the query plan once and use it forever. And people are going to argue that one is better than the other, but that's not our discussion.
The second of never doing force index, we've definitely seen cases where the all-powerful optimizer made some pretty bad choices.
Oh yeah.
You have to work around with force index. Any advice for because I feel like our site would be down with
As I said, in desperation, use it. Looking at all of these other issues, maybe you could add a composite index where you didn't have one before. Maybe you can drop an index which is confusing it. The optimizer's leaning toward it when it shouldn't. There are things that might work.
Any idea other than just black magic?
Hire me. No. No, I don't have black magic. The offset, read my pagination block. Remember where you left off rather than skipping over all that mess. That's the simple answer to that. The blog talks about it. The other part was, what again? I lost it. Temporary tables. Many of what I've described may handle that case. If you can show me the specific, I may have another suggestion. And as I say, temporaries are sometimes necessary. Can't avoid them. Live with it. So I don't have the simple answer for you. More? We use what for the optimizer? Hints. Optimizer hints. I do not recommend it because it's like force index. Today it'll work, tomorrow it won't. Tomorrow you'll need to remove it because the data will change. So there are cases, of course, where it should be done. There are cases where the optimizer isn't perfect. I say this even with the optimizer expert in the hall.
So what's the reason that I don't do an optimized table?
Optimized table.
So my situation is I have a 1 terabyte table that we purchased at 400 gig data, but it's not showing up.
Okay, the reasons for optimized table include defragmentation, and I claim that B trees keep clean enough so that, yeah, it's a little bit bigger than it should be, but you're not going to save that much, and as soon as you've done it, it'll get messed up again. The other case is it will redo the statistics. Well, analyze table is real fast and redoes the statistics, so no use optimize for that. Is there a third case? Did I cover the cases why you think you need an optimize? Yeah. It'll get fragmented again, so why bother? And you're taking down your system for a long time in order to do it. Now, PT online schema change is a way of avoiding it. You simply copy the table over. But that's a mess too. Okay. More? I'm being kicked out, so good time.